So what we're going to look at here is an example of how you can use the parallelogram method to add two vectors together. So in the question that we're given, we're told that we have two forces, a force of 22 newtons and a force of 26 newtons that are acting on the same object at an angle of 47 degrees to each other. We want to find the resultant force. Anytime we're asked for the resultant force, we know we have to add our two vectors together. Before we can add them, probably what we should do is we should draw a diagram illustrating our 22 Newton force and our 26 Newton force. So we'll draw a couple of arrows here. This one can be our 22 Newton force, and this one will be our 26 Newton force, just like this. Now, why have I drawn them like this? Because anytime we're told the angle between two vectors, we know that we have to place them tail to tail. So we've got our vectors tail to tail, 22 newtons and 26 newtons down here. And what is the angle in between them? 47 degrees. Now, if we want to add these two vectors, we don't want them to be tail to tail. We want to put them tip to tail. So what we can do is we can take this 22 Newton vector here, and I'm just going to copy it, and we can move it. That copy didn't work. Let's copy it again. And, oh, sorry, I want to clone this. We can clone it, and we can put a copy of it right over here. So it is, in fact, tip to tail with our 26 Newton vector. Because this is the same vector, we know that that is 22 newtons as well. The vector that we're looking for is the resultant, or the result of adding those two. So it's going to start from the tail of our 26 Newton vector and go to the tip of our 22 Newton vector. And if I dot in this last side up here, okay, this is why they call it the parallelogram method, because by making a copy of that 22 Newton vector and moving it over, I've made myself a little parallelogram. And the resultant vector is going to be the diagonal of that parallelogram. Now we want to use sine law and cosine law to figure out two things. We need the magnitude and the direction of r. So we need magnitude of r plus the direction. How can we go about this? Well, we're going to use the cosine law. We've got our 26 Newton vector. That's one side of our triangle here, formed by the 26 Newton, the 22 Newton, and our resultant. So we've got a side here, a side here. If we knew what this angle was in here, we could use the cosine law. Now, how can we figure out that angle? Yeah. 180 minus 47 degrees is going to give us 133. So if this is 133 degrees in here, we can now use cosine law to figure out what the magnitude of r is. So let's do that. We know that the magnitude of r squared, and I put that in the absolute value symbols because here we're only finding the magnitude. We're going to have to do a second step to figure out the direction here. But using our cosine law, 26 squared plus 22 squared minus 2 times 26 times 22 times the cosine of 133 degrees. And we can evaluate that. Okay? And since you've all practiced using the cosine law, we don't need to go into how you evaluate it. I'll just tell you that the answer you get is 44.048 degrees. Not degrees, sorry. The magnitude is 44.08, and it's going to be in newtons. Now, I told you on Friday that you should, it's a good idea to keep 2 decimal places. I'm keeping 3 here because this is an intermediate step in our calculation. Because we're going to be using that magnitude in the next step. So we've got the magnitude. We need to find the direction. The direction we can give relative to one of the vectors that we started with. So our resultant is here. If we find this angle in here between the resultant and the 26 Newton vector, we can use that to specify our direction. So we'll call this angle theta. And how can we figure out angle theta? Well, we know the magnitude of r, and we know that 133. So the length of this side and the size of the angle opposite. We want to find this angle in here. We know the length of the side opposite. So what can we use? This is just crying out for us to use the sine law. Absolutely. So let's set up our sine law. We're solving for the angle. So we put the angle on the top. Sine theta over the side opposite is 22. The other pair that we know is sine of 133 degrees over 44.048. And then we just want to solve this for angle theta. We're going to cross multiply, evaluate the right-hand side, and then take the inverse sine. And we end up with 21.4 degrees. Now we want to take our magnitude and our direction, bring them together to specify our vector. So what we can say is the resultant force is, we've got our magnitude, 44.05 newtons. So there I've rounded it off to my 2 decimal places. At an angle of, well, we've got our angle here, 21.4 degrees. And we also have to specify where that angle is measured relative to. So it was measured relative to our 26 Newton vector. So that's what we have to say. Angle of 21.4 degrees to the 26 Newton vector. And we're done.